if you apply function to a vector or a matrix, most of the case function will apply to each individual element and will return output as a matrix or as a vector. For example, if you look at absolute value function, we know it returns a positive value. So if we pass it to a vector, if we pass a vector into it, like 2 3 2 1, it will return, apply the absolute, take the absolute value of each individual element and return the answer as a vector. Similar thing happen if we apply it to a matrix. Okay, for example, let's say A is equal to 2, -2 and -3. Okay, and if we do absolute value of A, it will apply the absolute value function to each individual element and it will return a matrix. Okay. MATLAB expressions can be created using values, variables that have been already created, operators, built-in functions and parentheses. Okay, so you have already seen some expressions. For example, if the variable A is assigned the value 2, A times sine 2 pi plus 5 is example of an expression. So this is constructed from values, operations and variables. Okay, so expression don't have to contain everything. For example, 2 plus 5 minus 6 is also a expression. Okay, we can evaluate expressions. So expressions can contain these operations. Okay, you already saw these operations: negation, addition, negation, subtraction. Here negation, if we use it with a one number, we call it negation. So for example, when we look at -2, okay, subtraction, if we provide two operands like 2 minus 5, okay, and multiplication, division. So if I give 10 or 5, we divide 10 by 5 and get the answer 2. And if I give other way, 5 and 10, again I divide 10 by 5, I get the answer 2. Okay, and the exponential operators. Okay, like 5 squared, you will get 25. Okay, so when we have this operation, MATLAB uses operation precedence. That means if we have two operations, which one goes first? Okay, so this operation precedence have this following operators have this precedence: parenthesis goes first, explanations, negations, then multiplications and division and addition and subtraction. Okay, so for example, let's look at this expression. Okay, so here 2 multiplication have higher precedence of addition, so MATLAB will multiply 2 and 4, it will get 8, and then plus 5 is 13. Okay, and if you look at negation and exponent, here we know exponent have higher precedence, so MATLAB first will take the exponent and get 4, and then 4 times minus 2 is minus 4. Okay, again if we have this, minus 2, so here the things will work like this. First, highest precedence is this exponent, so it will take 4, and then negations have higher precedence over addition. This is not subtraction, okay, because this is with one element, it's negation, so this will become negative 4 and times negative 2, it will return a positive 4, sorry, positive 8, no, because 4 times negative, negative 4 times negative times negative 2 is positive 8, sorry. Okay, so again this negative, first it will take the exponent, it will become a 4 times negative 4, negative 4 times negative 2 is a 8. Okay, we can use a parenthesis to change the order of the operations, because parenthesis has the higher operation, highest precedence. For example, if I do 2 square, I will get a negative 4, but I can change this because the exponent goes first and then the negation, but I can change the order by putting a parenthesis and 2, I'll get a positive 4. Now negation take the first precedence, so you square the negative 2. Negative squared is negative 2 times negative 2, which is a positive 4. Okay, but if I don't have the exponent like here, first I take the exponent, so 2 to the square, 2 times 2 is 4, then you take the negation, 4 you negate it, you get negative 4. Okay, so here exponent goes first and then the negation. I can use the parenthesis here to change the order, so when I use the parenthesis, first goes the negation, so I get negative 2, negative 2, I take the exponent to the power 2, I get a 4. Okay, also I can change here, okay, we'll do the same thing 2 times, but this time I'll use parenthesis. Now what will happen, now 4 times 5 will go first, 9 times 2 is 18, no, this is similar to mathematics rules, okay, normal arithmetic precedence, okay, same as normal arithmetic precedence. If we have the same precedence, expressions are evaluated from left to right. Okay, so for example, again let's look at expression. Here we have plus division and multiplication. We know division and multiplication goes first. Okay, so multiplication and division are of the same level. If we do the multiplication first, I get a 4. 2 times 2 4, then I divide 8 by 4, I get a 2. 2 plus 2 is 4. But if I do the division first, I get 4. 4 times 2 is 8. 8 plus 2 is 10. Okay, so here I know division and multiplication are at the same level, but I go left to right there. So first I have to do the division. So MATLAB will do the division first. So you will get 4. 4 times 2 8. 8 plus 2 10. Okay, if we have nested parentheses, innermost parenthesis is evaluated first and then we go to outer parentheses. For example, consider this expression. Here innermost parenthesis is evaluated first, so I will add 2 and 1, I will get a 3, and 3 to the power 2 to the power 3 is 8. 8 plus 2 is 10, and then 10 times 3. Okay, so I get a 30. Colon operator has a lower precedence than plus. Okay, so for example, if I do this 1 colon 5, here the colon operator has a lower precedence than plus, so the plus will take effect first. So 1 plus 1 will become 2. 2 colon 5, it will create a vector from 2 to 5. Okay, but if we change the order and we do this, now it will create a vector from 1 to 5, then the array operation plus will add 1 to each element. So here you can see I get 2, 3, 4, 5, 6. No, here I create a vector from 1 to 5, and then you saw when we add 1 to vector, 1 is added to each element, so you get 2, 3, 4, 5, 6. Okay, this plus here is called an array operation. We will look at more array operations later. We already saw that addition added vector. We already saw that. So here one work as array operator and add each element to each, add one to each element in the array. Okay. There are other operators that work element-wise on arrays. They are this multiplication with a dot, addition symbol with a dot, and power symbol with a dot. Okay. So for example, okay, here this one work as an array operator and add one to each element in the array 1 to 5. Okay. So there are other operators that work element wise on arrays. They are the multiplication with this dot and this division with this dot and the left division with dot and the exponent with dot. Okay. So for example, if I have two arrays A and B 2, they have to be same size to do this element wise operation. 2, 3, 3. Okay, let's say this, and if I do A dot star B, they will be multiplied element wise. Okay, so first you can see 2 times 2 4, 4 times 2 8, 3 times 5 15, and 6 times 3 80. Okay, and if I do A dot division by B, each element will in B will divide elements in A. So 2 divided by 2 1, 4 divided by 2 2, 5 divided by 3 1.667, and 6 divided by 3 is 2. Okay, same way I can do A B. Now 2 raised to the power 2 is 4, 4 raised to the power 2 is 6, and 5 raised to the power 3 is 125, and 6 raised to the power 3 is 216. Okay, so these are element wise array operators. Recall that sign gives the radians values. Okay, so if we use pi over 3, we will get 0.8660. Okay, and here it shows up to 4 decimal places. We can use this format function to change this. Okay, for example, if I format long and then this will show up to, this will show more decimal places. Okay, also I can do short this will go back to 4 decimal places, and if I go format short e, it will give the scientific notation with 4 decimal places. Okay, here e to the negative power 1. Okay, so that is 10 to the power 10 raised to negative 1. Okay, 0.8660603 okay, times 10 to the negative 1. And if I use format long e, it will give scientific notation again, but here it will use more decimal places. Okay, so if we are looking at large numbers like real max, it's better to have it in scientific notation. Okay, also we have this format you will get answers in rational numbers. Okay, for example, if I enter 1.5, I'll get 3 over 2. Okay, so if you want to keep your answers in rational format, use this format rational. Every expression or variable has a type associated with it. MATLAB supports many types which are called classes. A class is essentially a combination of a type and the operations that can be performed on the values of that type. For example, there are types to store different kind of numbers. For float or real numbers, or in other words numbers with decimal places such as 5.3, there are 2 basic types, single and double. The name of the type double is shorthand for double precision. It stores larger number than the single type. MATLAB uses a floating point representation for these numbers. There are many integer types such as int 8, int 16, int 32 and int 64. Numbers are in the names represent the number of bits used to store the values of that type. By default, numbers are stored as double in MATLAB. There are many functions that convert values from one type to another. The type char is used to store either single characters or strings, which are sequence of characters, like cat. Both characters and strings are enclosed in single quote. The type logical is used to store true or false values. We'll discuss about these types in detail later.